The National Electrical Code, or NEC, mandates specific clearances for electrical fixtures in proximity to bathtubs, showers, and hot tubs to mitigate electrical hazards. For wall-mounted fixtures positioned less than 5 feet horizontally from the water surface, GFCI protection is a must. Concerning fixtures within 7.5 feet above the water level, they must be surface-mounted or recessed. These fixtures also need to feature a glass or plastic lens or glow, a non-metallic or electrically isolated metal body, and suitability for damp locations. Let's delve into the concept of electrically isolated trim. Electrically isolated trim signifies that the conductive metal components of the fixture lack direct contact with any grounded portion of the mounting surface or the electrical wiring. This precaution minimizes the risk of electric shock should the fixture become energized. Regarding skylights, electric skylights recessed into the ceiling must maintain a minimum clearance of 7.5 feet above the hot tub's water level. An electrical inspector's approval serves as a strong indicator that the installation adheres to NEC stipulations. An electrician's concerns might stem from articles external to the NEC, which might lack full applicability to the scenario. When evaluating electrical fixture placement, firstly assess the horizontal distance between the fixture and the water surface. If the fixture is within 5 feet horizontally, it necessitates GFCI protection. Secondly, consider the vertical distance between the fixture and the water level. If the fixture is within 7.5 feet vertically, it must meet specific criteria. These criteria include being surface-mounted or recessed, having a glass or plastic lens or glow, and possessing a non-metallic or electrically isolated metal body. Also make sure that it is rated for damp locations. Thirdly, confirm that the fixture's trim is electrically isolated, meaning no direct contact between conductive metal parts and grounded surfaces or wiring. Fourthly, for electric skylights, ensure they are at least 7.5 feet above the water level. Fifthly, check for listing by a recognized testing laboratory such as UL or ETL. This indicates the fixture has undergone safety testing. Sixthly, engage a licensed electrician for all electrical work. This ensures compliance with codes and safe installation practices. Seventhly, perform regular inspections of fixtures and wiring for any signs of damage or wear. Address any issues promptly. Eighthly, consult with a local electrical inspector for clarification on any code requirements or concerns. They can provide valuable guidance and ensure compliance with local regulations. GFCI, or ground fault circuit interrupters, are crucial safety devices designed to protect individuals from electrical shock. They work by monitoring the current flowing in a circuit. If a ground fault is detected, meaning current is leaking outside the intended path, the GFCI quickly trips the circuit, cutting off power and preventing potential injury. Ground faults can occur when electricity flows through an unintended path to the ground, such as through a person touching a live wire. GFCIs are particularly important in areas where water is present, such as bathrooms, kitchens, and outdoor locations, where the risk of electric shock is higher. The NEC mandates the use of GFCIs in these areas to provide an extra layer of protection. Regular testing of GFCIs is recommended to ensure they are functioning properly. This can be done by pressing the test button on the GFCI device, which should cause it to trip. If the GFCI does not trip when tested, it should be replaced. Understanding the principles of GFCI protection is essential for ensuring electrical safety in residential and commercial settings. Electrical isolation is a critical safety measure in electrical systems, aimed at preventing electric shock by physically separating conductive parts from ground or other conductive surfaces. This separation is achieved through the use of non-conductive materials like plastic or rubber, creating a barrier that prevents electrical current from flowing where it shouldn't. One common method of electrical isolation is the use of insulated wires, where a non-conductive coating surrounds the conductive core. This insulation prevents the wire from coming into contact with other conductive surfaces, reducing the risk of short circuits and electrical shock. Another technique is to use physical barriers or enclosures to isolate electrical components from their surroundings. This can involve placing components inside non-conductive boxes or using barriers to prevent contact with grounded surfaces. Electrical isolation is particularly important in environments where water is present, as water can significantly increase the risk of electric shock. In these areas, it is crucial to use equipment and wiring that are specifically designed for wet locations and to ensure that all connections are properly sealed to prevent water intrusion. Regular inspection and maintenance of electrical isolation systems are essential to ensure their continued effectiveness. This includes checking for any signs of damage to insulation or barriers and addressing any issues promptly. By implementing effective electrical isolation measures, it is possible to significantly reduce the risk of electric shock and ensure the safety of individuals working with or around electrical equipment. Regarding recognized testing laboratories like UL and ETL, these organizations play a vital role in ensuring the safety and reliability of electrical products. UL, or Underwriters Laboratories, and ETL, or Intertech, are independent testing and certification organizations that evaluate products to determine whether they meet established safety standards. These standards are developed by organizations like the American National Standards Institute, or ANSI, and the NEC. When a product is listed by UL or ETL, it means that it has been tested and found to comply with the relevant safety standards. This listing provides assurance to consumers and installers that the product is safe to use when installed and operated according to the manufacturer's instructions. The testing process involves a thorough evaluation of the product's design, construction, and performance. This includes assessing its ability to withstand electrical, mechanical, and environmental stresses, as well as its compliance with applicable codes and regulations. Products that pass the testing process are marked with the UL or ETL listing mark, which indicates that they have met the required safety standard. These marks are widely recognized and respected in the electrical industry, and they provide a valuable tool for identifying safe and reliable product. When selecting electrical products, it is always recommended to choose products that are listed by a recognized testing laboratory like UL or ETL. This ensures that the product has been independently evaluated and found to meet established safety standards, reducing the risk of electrical hazards. Consulting with the local electrical inspector can provide valuable guidance on electrical codes and regulations. Electrical inspectors are responsible for enforcing these codes and ensuring that electrical installations are safe and compliant. They can provide clarification on specific code requirements, answer questions about electrical safety, and offer advice on how to ensure that electrical work is performed correctly. Electrical inspectors typically have extensive knowledge of the NEC and local amendments, as well as experience in inspecting a wide range of electrical installations. They can identify potential hazards and offer recommendations for correcting them, helping to prevent electrical fires and shocks. Consulting with the electrical inspector before starting an electrical project can save time and money by ensuring that the work is done correctly the first time. They can review plans and specifications, answer questions about code requirements, and provide guidance on selecting appropriate materials and equipment. During the inspection process, the electrical inspector will examine the electrical installation to ensure that it complies with all applicable codes and regulations. This may include checking the wiring, grounding, bonding, and overcurrent protection, as well as the installation of electrical equipment and fixtures. If any violations are found, the electrical inspector will issue a notice of violation, which must be corrected before the installation can be approved. Consulting with the electrical inspector throughout the project can help to avoid violations and ensure that the installation is safe and compliant. It is essential to remember that electrical work can be dangerous, and it is always recommended to hire a licensed electrician for any electrical project. Licensed electricians have the training, experience, and knowledge necessary to perform electrical work safely and in compliance with all applicable codes and regulations. Moreover, ensuring proper electrical grounding and bonding is paramount for safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Bonding connects non-current carrying metal parts together to minimize voltage differences.